All right, we're going to return now to our addition models. In the first two cases, we looked at add-ins that had the same sign. So the idea is that you would want your students to start looking at examples like this and coming up with their own ideas about how they could do this without using either the chips or the number line manipulative to help them come up with the answer. So the next two cases would obviously be add-ins that have different signs. So we're going to look at the case of 2 plus a negative 3 to start with. Now again, I'm going to scoot this up since we've already looked at these two cases. We'll come back to that in a minute. And so here, this is telling us we want to join 2 white chips with 3 red chips. Now I've put them in a line here. You could do that, or you could do the 2 white chips and then the 3 red chips right underneath, whatever works better. But the idea is you want to then recognize that you've got these 0 pairs that are going to cancel out. I like this approach better where you line them up, because then you can say, okay, here's a 0 pair, here's a 0 pair, and it's obvious sort of what's going on, sort of by the way you write this out. So we end up obviously with 1 red chip, which is a result of -1. Now, the way we would do that with our number line model, and for those of you that were taught to immediately change subtraction to addition the opposite, you know, some of this may be a little strange when we get to subtraction, but you'll see how this works. All right, so again, remember that with the number line model, when you're doing addition, that means you're going to walk the direction of the second add-in. So we're going to start with modeling the first add-in, which is a +2. So we're going to go 2 units in the positive direction. Here's our +2. And now we're going to turn around and go -3. Up here, notice that the line segment and arrow that represents the -3 looks like this. So we're going to start from here, but now we're going to walk forward -3 units, and we end up out here at -1. Okay, so pretty straightforward. And then finally, this was our positive plus a negative case. Then we're going to switch that around and make that a -2 plus a +3. So again, with the chips, pretty simple. We've got 2 red chips. We're going to join that to 3 white chips. So if you do it like this, then these 2 reds and these 2 whites cancel, or you can line them up. So here's my reds, here's my whites. I want to scoot this up just a little bit more so you can see things easier. Here's a group of red and white that makes a 0 pair. Here's a red, white 0 pair. We're left with 1 white, so the answer is +1. Drawing the number line for that. Make a nice labeled number line. Now we're going to write the -2 on our number line. So we're going to go 2 units headed in the direction of the left. Second add-in tells us we're turning around, facing in the positive direction, and we make a step that's 3 units long, or a line segment 3 units long. Here's our -2, here's our +3, and we end up at 1. All right, so the number line models for addition are pretty straightforward, and so no big deal really with those. They're kind of what you might expect. All right, let's now move into subtraction. And the idea is we don't want to just tell them that with integers, subtraction is the same as adding the opposite. We want them to develop that on their own. So we're going to just give the students a chance to sort of use whichever manipulative, either the number line or the chips, or both, depending on how you're teaching and what age group you're teaching, and have them make that transition from doing it with a manipulative diagram to the abstract rules that we end up teaching them for adding and subtracting integers. So this time we're going to start with 2 minus 3. Now when we did this with whole numbers, you couldn't do 2 minus 3. That in our whole number arithmetic that we do in kindergarten through about 4th grade, this is a problem you would never give students because you're trying to take away more than you have. But now that we've introduced the idea or concept of integers, we're able to do problems like this. This now allows us to have something that's called closure for subtraction, which means that we can take any two integers, subtract them, and get another integer. So that's the idea for closure for subtraction. So if we're going to do this with the chips first, when we do subtraction with the chips, the minus sign stands for takeaway. Okay, so subtraction is a takeaway action. So what this is telling us to do is to have 2 white chips, take away 3 white chips. Sorry, this should be 3 white chips. 3 white chips. All right. So it looks like this. You start with 2 white chips, and the problem is telling us to take away 3 white chips. This is minus a positive 3. We're not going to change this to plus a negative 3 yet. We'll have them get to that after they've done it this way for a little bit so they understand why you can change that. So we do 2 minus 3. 2 white chips take away 3 white chips. But we can, hopefully, get them to understand that we can add as many zeros as we want. So if I add 1 0 pair, this is like adding 2 plus 0. So I still have 2 here, but I have 2 in the form of 3 white chips and 1 red chip. And so now I can do the action of take away 3 whites. I'm left with 1 red. So the answer here for 2 minus 3 would be -1. All right, that probably will take you a little getting used to because you're going to want to change that to plus the opposite of 3. But we don't want to do that with the chip model. The idea is we're going to do take away for our subtraction. And we have to take away what's told to us in the subtraction problem. All right, so how does that translate into a number line idea? Well, we said that when we did addition, join was the same as walk forward. So I'm going to slip back to that sheet I had a minute ago. So we said that addition here is join. When you do number line, add actually means walk forward. So again, with a number line, it all has to do with directions, which way you're facing, which way you're walking. So add means to walk forward. And when you're doing it with chips, you're joining sets. Now with subtraction, subtraction means take away when you're doing it with the chips. For the number line, subtraction is going to mean walk backward. So you're going to walk backward from the direction that you're facing. All right, so here's what it looks like. We're going to make our number line again, just like we have with all the other things that we've done. All right, so we start by representing our, if you remember in subtraction, the first number is called the minuend, the second number is called the subtrahend, and the answer you get is called the difference. So we're going to model the minuend, and so I'm going to draw a positive 2. So there's my positive 2. And now I want to walk backward 3 units, and because this is a positive 3, we're subtracting a positive 3, we're going to draw a representation of positive 3, but we're going to draw it by moving backwards. So I hopped up. When you see this hop up, that lets you know that you're doing something that's maybe different than what you would do if you were just adding. So I'm going to face in the positive direction because this is a positive 3, but I'm going to then walk backwards those 3 units to get over here to -1. Okay, so here when you saw 2 minus 3, it said start with 2 white chips, take away 3 white chips. When you see this as a number line idea, it's walk right 2 units, then facing right, walk backward 3 units. Now I'm using the term walk because you can actually physically have your students walk these problems out, put a number line down on the floor and mark it off with maybe some masking tape on the floor. And you can actually have them physically walk these until they get a sense of how this works. The idea of which way you face and which way you walk then gives you sort of the results that you're after. Okay, so here's the first example, 2 minus 3. All right, now we're going to do negative 2 minus 3. All right, so what's that telling us to do? Well, first of all, it's telling us to start with 2 red chips. So here's my 2 red chips. And now it's telling me to take away 3 white chips. Well, how in the world am I supposed to take away 3 white chips? I don't have any white chips. I have red chips. But we can always add 0 pairs. So I'm going to add 1 pair. Well, that still doesn't give me 3 whites. So I'm going to add another 0 pair. Still don't have 3 whites. We're going to add 1 more. And now I can do the required action, which is to take away 3 whites. So I'm going to cross off those 3 whites. That leaves me with 5 reds, so my answer then is negative 5. All right, so what is that going to look like when I do that over here with a number line? Oops, that's a positive one. Negative 1, negative 2, negative 3. All right, so again, we're going to model our negative 2. So we're going to have a line segment that goes in the negative direction, 2 units. Here's our negative 2. And now we're going to walk backwards, but we're going to face in the positive direction because we're taking away a positive 3. So I want to turn my arrow facing this way, but walk backward 3 units, and I end up out here at 5. Now that's probably not the way you were taught to do this, and I forgot to label these up here. The labeling just makes it a little easier for your students to kind of see what you're doing with your number lines. All right, so that's what negative 2 minus 3 would look like. Walk facing left 2 units, turn around, face right, walk backwards 3 units, you get to negative 5. All right, let's try another one. Let's say we now want to do negative 2 minus negative 3. Well, what in the world is this telling me to do? Well, first of all, we're going to have 2 red chips because you start with negative 2. And this is saying take away 3 red chips. Well, I have 2 red chips, but I need to take away 3. So I'm going to add 1 of my 0 pairs. But now I can do the required action, which is to take away 3 red chips. I'm left with 1 white chip, so the answer is a positive 1. All right, what's our number line interpretation for that? Well, let's see here. So we're going to start by doing a representation of negative 2. Again, we're going to head over to the left and make a line segment 2 units long with the arrow pointed to the left. Now we want to walk backwards 3 units facing the negative direction. So I'm facing the same direction, so I hop up so that I don't have a problem with what I'm doing. So I don't want to back over something that I've already written. I want it to be clear. And then starting from this point, I'm going to back up or take 3 backward steps up here to positive 1. So this is my negative 2, this is my negative 3. I end up out here at positive 1. And I'm circling my final answer so that it's very clear in the model what's going on with all the numbers. All right, well, let's try one more example then. What if I had positive 2 minus a negative 3? What's that going to look like? All right, so now it's saying start with 2 white chips, but I want to take away 3 red chips. Wow, I don't have any red chips, but we can always add our 0 pairs until we get enough to do the action. So I now have, again, before I do the action, if I would score what I have here, I've got these zero out, and I have 2, but now I'm going to take away the 3 reds. I'm left with the 5 whites, so I get a positive 5. What's that look like on a number line? Well, let's see here. Here's 0. 1, 2, 3, 4, 5. -1, -2. All right. So for this model, we're going to start with a representation for the positive 2. And now we're going to walk backwards facing left. So we're going to turn around and face the negative direction and walk backwards 3 steps, and we end up out here at 5. All right, so that gives us some examples that we can now look at. Now notice that in both of these, I have not used the idea of changing subtraction to addition of the opposite. We want the students to start to see, hopefully, a correlation. So, we've only done a few examples. If I go back to my addition sheet for a minute, I gave you 4 examples here, with the idea being that, let me zoom out a little bit on this so we can see all of them. Okay, so hopefully you can see all of that. All right, so we would want the students to do the problems with the models for a few days until they got sick of doing the models. The idea is for them to say, isn't there a faster, easier way for me to do this? And so here we would hope that they would see that if the signs are the same, we add the absolute values of the add-ins. The final sum has the same sign as the original sign on the add-ins. If the signs are different, they take the difference of the absolute values of the add-ins, and then they assign to the answer the sign of the add-in with the larger absolute value. And so hopefully they would come up with their own rules by looking at this. Then we would want to have them do some subtraction problems for a few days until they kind of got the hang of subtraction. And then we would want to give them several days worth of mixed problems where they were able to then compare what happens when you have problems like 2 minus 3, which is the same as this 2 plus a negative 3. We see that we end up with the same answer here. And that the negative 2 plus 3 actually gives us the same answer as, I'm sorry, wrong one, here we go. Maybe I didn't do it. Oh, here we go. Nope, I guess I didn't do one like this, the 2 plus a negative 3. But we do end up with the same answer as this problem here, so I guess maybe this is where I was going. But the idea is we want them to start to see, oh, if I change the subtraction to addition of the opposite, then I can get the right answer. So we want them to come up with the rule or the definition that if you have A minus B, that's the same as A plus the opposite of B. And so this is our rule for subtraction. So once you change all of your subtractions to addition of the opposite, then you only have to know the addition rules to do the problems. All right. That ends our review of how to use the models, the chip model and the number line model for adding and subtracting integers.